we'll go ahead and kick things off. Thank you, everybody, for joining early or late. It sounds like we've got everyone all over the place. So welcome to DAST is Dead, Long Live DAST, the evolution of dynamic API security testing. My name is Nicole Jones. I am a product marketing manager at StackHawk, and your host today is Scott Gerlach, our very own CSO and co-founder. And we're going to dive into the transition from what you may know as DAST in the past to a more modern version that covers not only application security testing, but also API security testing. So I'm going to turn it over to Scott to kick it off for us.
Yeah, awesome. Thanks, Nicole. Welcome, everybody. Thanks for joining. I only know how to do Guten Nacht, Deutschland, so I can't do good evening everywhere else. Apologies. But I can also do it in English, so good day, good evening, good afternoon, wherever you are. Thank you for joining us. Nicole and I were just talking about where did DAST is Dead, Long Live DAST come from, which was a whole educational thing, but that's kind of the position I like. DAST is dead, long live DAST. So let's talk about some of the things that we're going to cover today. So first of all, we're talking about some of the legacies of downfalls. Wow, the legacies of downfall DAST, the downfalls of legacy DAST, some of the API security market demands, debunking the doubts around DAST, and the benefits of modern dynamic API security testing. Nicole just dropped a poll up into the webinar here, so please pick your flavor of what kind of work you do. And then at the end, we'll have Q&A. Obviously, we're already doing some chatting. You have access to the Q&A panel, so if you've got questions, let's make it interactive. Chat, drop some questions in the Q&A. And then, as Nicole mentioned, remember to stay tuned to the end of our webinar for a special treat for our live attendees. This is only for our live attendees, so if you are watching this recorded, sorry, but our live attendees who stay up late, get up early, or middle of the day, and join us, get a special treat. Who am I? As Nicole mentioned, I'm Scott Gerlach, CSO and co-founder of StackHawk. I was the CISO at SendGrid for about 3 years. I was a senior security architect at GoDaddy for about 9 years, a little bit more than 9 years. I'm also what about DevOps engineers doing security work? That, I would go maybe developer transferred to the dark side on that one, but I apologize. We forgot that one. I'm also a husband, dad, golfer, brewer, tinkerer. If you want to talk to me out on the interwebs, you can hit me up on X, Twitter, at sgerlach. And then, of course, my LinkedIn is there, Scott Gerlach. So let's talk about some of the downfalls of legacy DAST. The doubts about DAST didn't sort of manifest out of thin air. It's true that DAST, most of us are familiar with, and I'm familiar with, I used for a long time, falls short in what organization security teams need. They often end up testing in production, which leads to all kinds of inefficiencies, especially prolonged feedback loops. The people who are fixing the problems, the development team, are the last ones that know about them. Scans are kind of neutered or tamed a little bit to avoid hurting production. So if you're testing with DAST in production, you always go, all right, turn off the things so I don't take down production. And then it ends up being very black box. So very black box insofar as I don't really understand how this application or this API was built. So I'm testing for everything possible, which leads to long scan times as well as false positives. DAST is hard to scale. The naysayers here aren't completely wrong, but legacy DAST lacks a lot of automation and it doesn't align with developer workflows at all. So usually you're talking about a development and an agile development workflow that is build, test, publish quickly, and iterate. Legacy DAST doesn't really help with that. It is more of a point and shoot at a URL in production to do testing, and that's not awesome. Those scans then end up taking a really long time, and they're a little bit disruptive, and that's due to a couple of things. A, you probably slow it down so you don't hurt production infrastructure, and B, because scanning over the internet has a lot of round trip time for HTTP requests, takes a long time. There's a good question. Why would I run DAST in prod? It's a huge load. That's a great point. It's also why we're here. Okay. And then maybe one of the most important things about legacy DAST is it just lacks API specific testing capabilities. So they were designed to test Web 1.0 applications. They really don't test API endpoints directly, leaving organizations with unaddressed security vulnerabilities in their API layer. And there's a ton of stuff that turns into. So that whole Web 1.0, we're going to talk about some of this, turns into some problems with when you get to Web 2.0 and some of the challenges that legacy DAST might have. The need for dynamic API security. So DAST, look at this. Look what we did here. We're sneaky. Dynamic application security testing, dynamic API security testing reflects new realities in software development today. So a bunch of research has been out there, has been done and is out there, which you can read here, which is an insane kind of number. So the 80% of internet traffic coming from API calls is, like, if you think about it, it makes a lot of sense. You've got cell phones and you've got all kinds of other stuff that are just basically making API calls all the time, right? That's how they function. But so is so many other things, whether that's B2B services or machine to machine services, or even single page app front ends. They're all calling APIs, and the APIs make it a very scalable function, which is why everyone's building it. And then if you take that in conjunction with the rate at which APIs are getting developed, that totally exceeds the rate at which most organizations can ensure the security or even know about APIs that are being developed. So if you think about, I always think about APIs being akin to what we used to call legacy applications, Web 1.0 applications, but they're a little bit different in how they behave and how you'd want to test them, as well as how you get to know about them. So let's talk about how kind of API-centric application security should work. So this is very similar to application security, insofar as when APIs are being developed, when a team writes an API, they know the syntax isn't quite right when it won't compile, or an editor IDE is going, hey, there's an error in this code, right? So we're telling development teams about that really early and upfront. And then when they merge that API code, they know there's a problem when it won't merge. So there's some kind of conflict in the code. Again, there's a problem in the code. We're telling development teams about that early. And when you run unit tests, they know when the unit test fails, there's something wrong. Again, early testing, early feedback loop, early fixing. And then when a team runs API security integration tests, they know the code is wrong because it doesn't work as it's supposed to, as it's designed to. I'm uncertain why security has been left in the dark in here, but it definitely has. When a team introduces an API vulnerability, they have no idea because nothing is telling them. So some of the common misconceptions about DAST is what we're going to cover next. Nicole, I think we have this slide, right? I think another poll is coming. Here we go. Another poll question: DAST woke or broke? Would love to hear your feedback here, but some of the common misconceptions of DAST, it's not uncommon for me to hear directly from Jim Manico, DAST is dead. Now, Jim and I have since hashed this out a little bit. And when we talk about this, we talk about legacy DAST. But I've also heard things be said that says we can't use DAST because we only have APIs. And that was a CISO. I was talking to a CISO and I was like, what kind of things do you use? And what kind of programs do you develop? We usually do APIs, developing APIs. And I was like, what kind of security testing do you do? And he asked me, what do you do? Obviously. And I said, we do dynamic application security testing. And he said, oh man, that's a bummer. We can't do that because we have APIs. And I was like, what? Let me talk to you for a bit. It was a really good conversation. But that misconception was crazy. And as a CSO of a company that's 100% focused on the business benefits of DAST, I can tell you that these statements are misinformed. Modern DAST, hey, let's do the StackHawk things, has evolved to keep up with the way we build software today. And we built the company and the product because of these challenges, right? The shift to APIs, the shift to DevOps, the shift to speed. We built the company, we built the product to help these things. Now, this is not just all product pitch. We're going to talk some more about some of the things that are going on here. But dynamic application security testing, I like to think of it as I always envision it as a rotating A on our website, which we'll see if that happens, where it's dynamic application security, dynamic API security, dynamic AI security. We'll see how that works. So here's the reality of dynamic application security testing, dynamic API security testing, and what it does in the world of API security. If you look at a survey, which we're going to look at next, modern DAST solves for 60% of the worry in API security today. That's a big number, and you might not think that that is true, but check this out. This is the state of API security report from Q1 to 2023 from Salt Labs. Now, their report says stuff like it's our API security program today is too cumbersome and slows down delivery. It doesn't invest enough in pre-production security. It doesn't focus enough time on fleshing out requirements and documentation. It doesn't adequately address runtime or production security. And then it doesn't drive enough observability and control. And then there's that 4% of random other answers. Now, the thing that's funny to me is if you take a product like Salt, which is a great product, they're a good partner of ours, they cover that runtime or production security, that production security monitoring, alerting, and then also the observability and control aspect. But they also don't hit that kind of right side of this pie chart, where I think API security has a lot of benefits and a lot of optionality to turn into where these things can be effective. And spoiler alert, modern DAST excels at each of those things where it's fast. It is investing in pre-production security. If you're able to test during development phases while people are building software, that helps that pre-production phase. Focus time on fleshing out requirements and documentation. I think both of those things are a little bit of a necessity to be able to test APIs pre-production, but it also kind of forces the conversation a little bit more. So having tooling and optionality programs to be able to say, hey, we want to test these APIs as we're building them. Let's make sure that we document them. And as we find problems, we'll fix them. So let's talk about some of the OWASP API top 10 and how this might flush into our modern dynamic API security testing. Hopefully everyone knows all about the OWASP API top 10. Nicole just launched another question for the types of APIs that you might be working on at your company. Oh, look at that. Just everyone all over the place. Awesome. Thank you for answering these poll questions. It's so awesome to have interactive people. So we're talking about the OWASP API top 10 here. Now, the OWASP API top 10 is very specific to APIs. Love to see that gRPC. Very specific to APIs because of how APIs operate. Now, if you take a look at most of these things, you're talking about broken object level authorization, broken authentication, broken object. These are my favorite acronyms. Nicole loves these acronyms. I love these acronyms. BOLA, BOOPLA. Everyone say it with me, BOOPLA. Next time you're at a security conference and you're talking to somebody, you'd be like, I'm worried about BOOPLAs. And they'll be like, what? And then you can say broken object property level authorization, BOOPLA. Unrestricted resource consumption, broken function level authorization, unrestricted access to sensitive business flow. So, tenancy checks, those kinds of things. It's talking about when cart checkout actions are happening, those kinds of things. Server-side request forgery, security misconfiguration, unsafe consumption of APIs. That's rate limiting. Now, I always look at these things and I go, wow, there's so many security testing tools out on the market. How can I get coverage on some of these things? And I know for a fact that a lot of security testing tools don't cover these things. So if you think of software composition analysis, SCA doesn't really fit into any of these things, doesn't cover any of these broken logic type opportunities for misuse. SAST might be able to do a couple of these things, static software, static analysis, static application security testing. There we go. Wow, it's early. Apparently I need more coffee, Nicole. SAST doesn't really cover a ton of these things. Maybe server-side request forgery, maybe broken authentication, maybe. But it's really hard to be able to do some of this. This is very logic testing, logic-oriented testing, and it doesn't cover a lot of these things. That's where I think this is really cool. So dynamic API security testing covers most of these things, and that's because to be able to test a ton of these API top 10s, you have to make requests to the running API and get the responses. And that is exactly what DAST excels at. So if you're talking about broken object level authorization, you can maybe see that in an API spec. Like if you're looking at a REST API, you can maybe see that in the spec, but you can't really test for it unless you make requests to the API and see how it behaves. And the same thing is true for, 9, let's see, what did we say? 7 of these different OWASP API top 10 attacks. Now, improper inventory management, that is a special little guy that I think StackHawk covers very well with the way that we map software repositories to applications under test in our product. So, I give a little StackHawk caw on that one, but the other ones are very DAST specific, especially unsafe consumption of APIs. If you can get your DAST to run effectively, you are not rate limiting your API. Now that's a weird conundrum, right? That's a weird, okay, I want to be able to test, so I should turn off rate limiting. And then when I turn off rate limiting, I get a thing that says, hey, unsafe consumption about APIs. Yes, but you can always turn off rate limiting in pre-production, do your testing, then push to production and do some passive testing in production. And if you get rate limited there, you're in good shape. If you don't, that's a problem. We got some chats going on here, Nicole. What are we talking about? Yep.
I think partially what some people are here for, and we got a couple good questions.
Yeah. So one question, I noticed a lot of DAST scanners that scan APIs rely on OAS files to become aware of endpoints to hit. What about RAML? Okay, so I haven't heard of RAML. You might have to give me a tip on that one. It's a bit more niche, but a lot of low code tools use it, like MuleSoft. RAML to OWASP, OAS, Open API Security. No, sorry, Open API Spec. There we go. Jeez. So many security things. Doesn't always cleanly convert. How does StackHawk become aware of endpoints to hit? That's a great question. It's we planned a slide for that. It's like 2 slides away. Too many acronyms. I agree. Here we go.
So many acronyms.
Yeah, my wife always goes, I don't know what you're talking about. You just said 50 acronyms right in a row. And I'm like, oh yeah, sorry. I forgot. So here's what I think DAST does a really good job of testing for in API land. And because of that whole request response necessity. But don't forget, the regular OWASP top 10 also applies to a ton of APIs. So all the things that we're talking about in the regular OWASP top 10, the ones that got have the little gear icon, those also apply to APIs. So if you're talking about stuff like injection, whether that's SQL injection or command injection or potentially XSS injection, depending on the contract you have between whatever's handling displaying of that data. insecure design, security misconfiguration, like all of these things also apply to APIs. So you've got an API list that is very specific to APIs, and you've got the regular list, which some of these have been translated into the API ones. So the ones with the OWASP WASP icon, those have been translated. So broken access control, server-side request, forgery, authentication, identification, and authentication failures. Those ones got translated into some of those API specific ones. Why they have different names, I don't know. I have to talk to the OWASP committee about that or get on it and change it. Anyway, boopla. The other ones that are in here also apply to APIs. So you always have to think about that, and it makes testing very hard. It makes API testing very hard. So if you're very specific to API testing and you're covering the OWASP API top 10, you might be leaving out the regular OWASP top 10. Now, that might not be true. That might be true. But being able to automate all of this stuff so that you can, as we're designing our application security programs, I always say, make sure you design your application security, API security program to cover kind of that 80% rule. So you're covering how most of the applications and APIs are built in the company. And if you have zombie APIs that people have left out there, or you have a niche thing that somebody's working on, you have the time and the ability to spend more manual resources on, because your 80% rule is covered by more automation, more standardized testing. What tools do you recommend for API and ensuring 100% coverage? That's a great question. I would say StackHawk, but I'm pretty highly biased. So let's talk about some of the benefits of modern dynamic API security testing. So API-centric expertise, the ability to test all of those different APIs that we talked about earlier, then you so graciously filled out our poll for, whether that's REST, SOAP, GraphQL, and or gRPC. Unlike those legacy tools, modern DAST solutions are built to address the unique challenges of API security. They possess in-depth understanding of API-specific attack vectors, authentication mechanisms, authorization workflows, and that special knowledge equips them to excel in securing modern API-driven landscape. Automation is one of the big keys here, streamlines the testing process so you can build testing workflows into your continuous integration, continuous delivery workflows. So if you're thinking about, stuff like, hopefully you're not using Jenkins, CI, or GitHub Actions, or GitLab and the CI processes there, you want to be able to build those application security testing processes, API security testing processes into those CI/CD functions, so that while developers are building code, delivering code, testing code, they can get that feedback very quickly and while they're still working on it. So instead of, I published it in some period of time, whether that's days, weeks, or months later, they learn about application API security problems that they've introduced. And then lastly, to be able to, maybe not lastly, being able to test quickly is really important. So being able to test smaller bits of API. So as you're developing microservices, thinking about testing a microservice, thinking about testing a microservice as it's built in with other services. So I'm going to invent a term right now, macro service. As you think about those microservices that build into an API, being able to test them standalone and then test them integrated, just like you would in CI functions where you're doing unit tests and integration tests on the microservice, and then unit tests and integration tests on the combined service. That's important to do with security testing as well. And one of the standout features of dynamic API security testing is a lot of speed. And so when we think about speed, we think about not only the round trip time latency for HTTP calls, but also more of a gray box approach to how we're testing. So being able to say, we built this API with Java, and we built it with PostgreSQL, and we built it with, I don't know, whatever else. And that's the only tests we want to run. because we know how we built it, because we have access to our development teams, we have access to our software repositories, and we can see. We're not playing, I don't know how it got built, so I'm going to test for everything. Really increases speed, reduces those false positives. And that is super important. Like I mentioned, testing before production accelerates that find and fix cycle, hopefully getting that information to the people who can fix that code really quickly. And when you combine those two things with stuff like static application security testing tools, Sneak and GitHub being some of our favorite friends and partners, being able to correlate those two findings against those smaller services really gives you a lot of, here's the problem in a running API, and here's the code where you should go fix it. Really helps those developers get to, oh, I see, it's broken, I'll fix it, and then move on with their lives, get back to producing value for the company. Being developer friendly is super important. How you talk about problems, how you show recreation steps, how you show where and how to be fixing these things, and then how to retest is super important, because if you make the security team the linchpin, the pivot point between all those communications, it becomes ineffective, because as security professionals, we are crazy busy. I don't know if everyone is aware of the kind of standard accepted ratio of developer to security teams. I love this ratio. I think it's low, but it really shows how kind of overworked, under provisioned some of our security teams are. And it's 100 developers for every one security person. Yeah, definitely overworked. Got you. I'm with you here. This is why we want to be able to automate a lot of these functions and give the information that is appropriate to the right teams, because we can hopefully extract ourselves out of that. I got to review these things. I got to make tickets. I got to go bother people. I got to beg and plead for someone to fix something. If I can get them the information at the right time, hopefully they're building and securing those problems. Lastly, logic testing in API security. Modern DAST tools are excellent at testing for logic-based flaws in APIs because of what we talked about, that whole request response. You got to see how the API reacts and interacts. And really the only way to do that is by testing it with something that makes requests and responses. Usually you catch these things through bug bounties, let's be honest, or by testing those things manually yourselves. DAST is a really great tool that helps suss out some of those things. Let's see. All right. How about IAST in API? You know, this is a great question I hear all the time about IAST. And I think IAST is really strong because it can help point to lines of code where problems exist. And I think our API security partners are really strong because they help point out problems in APIs that are actually happening in production. So as people are attacking an API, you want to know about that so that you can take mitigating actions and then hopefully go fix them. But the things that don't happen there are, if APIs very specifically don't get traffic, both of those things don't work. So if you've got I love that everyone talks about shadow APIs and zombie APIs, which mean APIs I don't know about or APIs I do know about and no one is developing anymore. That's what that means. Both of those things happen to need traffic. So if you're talking about IAST, you have to have attack traffic happening to it for it to do something. So that's why it pairs nicely with DAST, because DAST is doing attack traffic. If you have IAST, now IAST has its own deployment issues. If you have IAST in there catching those attacks and going, actually, this worked, and here's the code, that's a really nice partnership and pairing between those two tools. But it can be difficult to deploy, to get DevOps teams to include in software stacks. And the thing that I've always found, because I've deployed IAST before, the thing that I've always found is it somewhat turns into a little bit of a black box, and then something happens, whether it's a performance problem or some kind of something's not working quite right, and the black box is the first thing to get ripped out. And then the API security tooling, that also has to have traffic. So one of the benefits that API security tooling talks about all the time is being able to inventory and look at APIs that are being deployed and used in the company. The challenge can be there with how you deploy APIs. So if you're deploying API security tooling on an API gateway, if someone's not using the API gateway, you're not going to see the traffic. Similar with many deployment styles. And then this last part of that is if part of an API or an entire API doesn't have traffic and it can't see it, it's not going to tell you about it. It's not going to magically go, hey, there's an API over here that no one's using that has a vulnerability in it until someone tries to exploit it. Now, the way that we think about APIs is source code is the source of truth. And so the way that we talk about APIs and mapping how we test APIs to source code and how those things tie together is very much needs a specification. And specifications, API specs, OAS, Open API spec. GraphQL is great because it kind of auto builds introspection queries, and that's how you get to know that. SOAP is great because you kind of have to build a WSDL to be able to understand how the SOAP engine works. And gRPC has that same kind of reflection point where it automatically builds reflections that describe itself. REST is the only one that kind of sort of got away with, hey, you don't really have to build information about how this API works to use it. However, almost every single framework to build REST API today has the ability to automatically build an Open API spec. And that is the number one way to do it. Automated Open API spec building is the best way to do it because the code will generate the documentation and it is correct. Hand building Open API specs works, but it's not awesome. The last thing to remember about an Open API spec is that it is not a contract. Sometimes I think people think that an Open API spec is a contract in how the application itself works. So defining things like you can't stick strings into this parameter. It's only integers. You can't stick really long data streams into this parameter. If the Open API spec says it's a max length of 24 and it hasn't been generated by code and the code isn't checking for that, that's the only thing that's going to prevent like long strings, integers instead of strings, UUIDs instead of integers. The code is the only thing that does that. The Open API spec doesn't enforce any of those things. So some of the questions that came up here were about not having an Open API spec, for instance. Oops, look at that. Too many clicks. Hey, our API doesn't have a spec. So in this case, we always talk to customers and some of our prospects about how does your development and QA team test their API? So whether that's Postman, Cypress, Selenium, or some other testing framework that is being used to run tests, all of those can be used to test APIs with DAST. So a couple of really cool things, built-in Cypress, built-in Postman, built-in Selenium, abilities to test, but also the ability to take in traffic recording. So hopefully everyone knows about a HAR file, an HTTP archive file, Read API Pro. I've never heard of Read API Pro, but if it does stuff like can transfer to Open API spec, yes. But I'll have to, Nicole's taking a note right now for me to look at Read API Pro.
Yep.
But thinking about how you're interacting with an API service, whether that's clicking around through a single page app, running Cypress tests, running Selenium tests, being able to record that HTTP traffic and analyzing it for use in testing is also very important. So instead of just record it and play it back, record it, analyze it, figure out what the parameters are, what the endpoints are, what the what kinds of data, what kinds of real data go into those things can all be extracted out of that HAR file. But again, the spec is the 100% best way to do it. So having code auto generate the spec, open API spec, REST APIs. I'm looking at you. We gotta get more automated definitions kicked out, like more of the other API tools. Again, the code produced API documentation is the best method. Some of the new realities in software development. So we already talked about APIs revolutionizing how we build and grow our digital presence. Companies are building APIs at a phenomenal rate because they are so quick to deliver value. Effective collaboration between security and engineering teams is crucial to scale these operational efficiencies. The days of a siloed security team who doesn't talk to anybody, puts tickets into a queue and hopes that they get done, those days are coming to an end because it is super inefficient, doesn't help the business achieve its goals. Greater discovery into unknown APIs and applications is vital to prevent potential threats. So being more tightly coupled to what engineering teams are building, how they've built them, what they're thinking about as what the value is they're trying to get out of them, seeing what things are being developed and then turned into production and just monitoring. Like they're making money, but we're not continuing to build on them. As well as seeing the things that are popping up as brand new. So the very first thing that we do when we create a repository, sorry, I was reading a question and I totally brain locked. As a new repository pops up into your repositories, in your GitHub or whatever, that's a pretty good indication that a new application or API project is kicking off. So being able to go, oh, who's working on that? I should talk to him about it. Let's start testing it as quick as possible. Super important to make this really efficient. And then automating those security tests and kind of that security program into development workflows that helps our development teams is essential for faster time to fix ratios. So being able to understand what's wrong quickly, speaking developer language and getting that information to them helps them fix. It's so weird. I know we have some devs on here. We asked hundreds of devs when we started the company, hey, if I could get you application security problem information, a security bug information early in the process, what would you do? Almost every single one of them said, well, try to fix it. Because it's like a bug to them, right? They take pride in the software that they're building. They want it to be performant. They want it to be bug-free. Security problems in these APIs and applications are bugs until they hit production, then they're vulnerabilities. They think about them as bugs. If you can get them that information, they often want to fix those things. A little bit of StackHawk, our new favorite tagline. API security testing that doesn't flock around. Come check out StackHawk and what we can do around APIs and API security testing. Tons of the stuff that we've been talking about today, strangely, is what we're really good at StackHawk. And this is stuff that the co-founders of the company, myself and Joni, have experienced in previous companies, working as Joni was a product leader, having that frustration of, hey, you got to stop doing everything so you can fix all of these tickets. And my background as a CISO and an application security person, trying to keep up with engineering teams and the speed that they're going at, as well as, man, I wish somebody would fix something, is really what led us to what we built here today. So that's pretty much it. Let's do some Q&A time. I got one question already up. More questions coming in. I love that. Don't forget, there's a special thing, so hang on with us. I know we're 40 minutes in, so we got less than 20 minutes left. Well, depending on how long the questions are. Very first question, securing your APIs, ever heard of server-side rendering and generation? I'm not sure that that's a question. Maybe it is. Maybe add some more information to that if you'd like us to answer that question. Somebody asked how StackHawk is priced. StackHawk is priced per code contributor for applications under test. If we're helping those code contributors build more secure software, we like to tie closely to how that works. Curious what specific things you're doing around GraphQL. So GraphQL specifically, we're doing a lot of some of the Open API top 10, all of the OWASP API top 10. So we're talking about injection things. We're talking about some of those other problems that appear in GraphQL, and we continue to build out functionality in all of our API testing capabilities. So as we get into more and more GraphQL, we're talking about some of the static testing, which is recursion and some of those infinite resource problems. Let's see. How can you perform auth tests on my pipeline? I think if you mean in the pipeline, we can definitely do authenticated testing in the pipeline. If you're talking about on the pipeline, maybe. It depends on the pipeline. It depends on what you want to test for. If it's got HTTP endpoints, we can absolutely test that. Be curious to see what other things you might want to do there. You wanted to elaborate on DAST scanning in production, pros and cons. Yes, so DAST scanning in production, pros and cons. I like DAST scanning in production. Now, I usually have confidence that I have confidence that what our scanner is doing is not going to make a mess on our application. So we use StackHawk to test StackHawk. It's a weird inception problem. But I know that it's not going to create a mess. Now, in some other applications where you've got the ability for a user to create comments or create, something else that someone else sees, that could be a problem, but we have the ability to turn off a lot of those tests to have a more nuanced, less intrusive test in production. Now, this is absolutely the reason I like testing in pre-production, because you can make it run hog wild. Like, do the most aggressive active testing you can. Tell me about my problems. Hopefully I'm using a seed database. Hopefully have the ability to restore that. Hopefully I can wipe out all the testing that has happened there to be able to get to clean state. And then ultimately what you get being able to test pre-production is you can test those smaller microservices. And those tie more evenly to the teams that are working on the code. You can also test in CI/CD in those pre-production environments. But I don't shy away from production testing. I just think it shouldn't be the first, last, only place that you test. Wow, so many questions. Open API specs are a must-have for DAST scanning a RESTful API. But typically, if I provide a Swagger file to a DAST scanner, either commercial, the DAST scanner doesn't actually know what values to provide in JSON payloads and tends to revert to brute forcing. Responses are typically 500 and scan times are bad, or rather numbers of requests sent to valuable response received is a really bad ratio. This is a very long question, but it is so good. I'm hearing you evangelize for DAST, but I'm not hearing how you solve for this. How do you leverage open API specs and improve scan results? So this is one of the really important pieces of being able to test an API. Swagger files, open API specs, interchangeable, and they usually define what values in parameters should look like. Now, most modern testing engines can create values that look correct, but the key there to drive a lot of URL-driven parameters and functions is being able to provide actually correct information. So that's one of the things that we do in our APIs is be able to say, here are actual values that need to be driven into some of these parameters to drive APIs correctly, to undo those 500s and bad scan times. Now, we'll also drive bad information into those things to see if the API is responding to them correctly. The way that I usually explain this is if you've got a silverware drawer, and in the silverware drawer, you have slots for a fork and a knife and a spoon. And the only way that they work is by putting in a fork and a knife and a spoon. Your DAST scanner, your testing tooling has to be able to understand that. This has to be a fork, and this has to be a spoon, and this has to be a knife. Now, the other thing that we'll do is try to jam a couch in there. I was trying to just jam a couch into the silverware drawer and see if the silverware drawer is like, yeah, that's cool. Would you like free tokens to something? I don't know. But both of those things are very important in API testing. And both of those things are stuff that we cover in modern DAST. How do you cover your behavioral scenarios such as BOLA? Do I need to input my user hierarchy? So today, yes, you kind of have to know a little bit about how your API works to be able to write those kinds of tests. However, some of that HAR recording stuff is sort of the new way that we're thinking about that as well, to be able to add additional tooling. So if you're testing if your QA or engineering teams are using Selenium tests or some other kind of test to do some of that integration testing, we can take a look at that traffic, develop tests, and build upon them to be able to test for stuff like BOLA, BOOPLA. StackHawk's policy around data residency. All of StackHawk's services and data are United States based today. Is what it is. Business logic vulnerabilities. I just covered that one just a little bit. Will StackHawk work with ADO in CI/CD? Absolutely. We have hundreds of APIs, but have very open API schema. Should we have open API schemas to test? Yes, I covered that a little bit. The most effective way to test the REST API is for the code to generate an open API spec. Now, I understand that that is not the only way that people build software. It's not the only way that people test software. It's not the thing that happens more often. But if you talk about always talking to the engineering and QA teams, how are we testing this thing? How are we doing active tests against this open API? Most of those things can be fed back into a next-gen DAST testing engine. What offering we expect from you for ST to build solution? I'm not sure I understand that particular question. What offering we expect from you for ST to build solution? If you want to rephrase it a little bit for me, I'll try to answer it. GitHub specific questions, any capabilities on flowing DAST security findings back into GitHub Advanced Security using Serif file formats. Any thoughts? Great question. We had this capability, are continuing to work on this capability, and are in fact working with GitHub Microsoft about the Serif format because Serif does not serve dynamic testing well. The Serif format is very much geared to static findings. So like the very first paradigm in a Serif file format is what file is this located in? And that is not how DAST works. So we're working on making that improved and getting it better and better. We have the ability to do this in some of our older versions, and the newer versions of HawkScan, the StackHawk testing engine, will have this as well, and it will be even better. These are great questions. Thank you so much for engaging and asking questions. Let's talk about some next steps. After the session, we'll send you the recording, the slide deck, and additional resources if you want them. If you're interested in seeing StackHawk's dynamic API security testing in action, book a meeting, and I'm going to give you a resource for that. For those of you who attended today, those of you who are watching this in a recording, visit stackhawk.com and reach out to us with any questions via chat on our website or in the StackHawk platform. Both of those things will work. Let's see. A new question.